Hello everyone, I hope you all are doing great. Welcome to the seventh lesson in module 4. This is the last lesson in this module. This is about absolute value functions. If you recall, we have already studied about absolute value functions earlier. So we will add on to it. We had not studied the graphing part and now we will be studying the graphing part over here. Now then, the learning objectives of this lesson are graph absolute value functions, apply translations to absolute value functions, apply dilations to absolute value functions, then reflections to the absolute value functions, and lastly, to interpret constants within equations of absolute value functions. There are plenty of objectives. We will cover each one of them in this video. There are many problems in this. But before we continue, I just want to quickly remind you to watch the previous lesson, the transformation of graphs. It is, I think, so 4.4 in this module. So please watch that lesson because we have learned the transformation in Desmos and everything. It's in detailed explanation of graph transformation is explained in that lesson. The same knowledge will be applied over here. It's only that the graph will be different. It will be like a V, absolutely. We'll see that now. Before that, the keywords are only two: absolute value function and vertex. So now let me just draw an absolute value over here. So imagine this is something, an absolute value. If this is the, sorry. Anyways, this is something like that. Now, if you have a axis, and now here you can see this is at the right side but down. So what is this? Say this is about -5 and this is about 6. Okay, here you can see there is a change in the absolute value function. Generally the parent function will be always at the center 0 0. What has happened here? It has moved to the right by 6 units. So the translation to the right is 6 units and down it is 5 units. So this is basically the translation from the 0 0 point, the parent function, it is moved to some other point. This is the change. So you can see, we can easily trace this: 6 units right, 5 units down. But we will see from the equation how it is, because this equation will generally be written as absolute value -6 -4 -5, sorry. So how to interpret this equation, how to understand this? Now that is what we will be learning mainly. That's about translation. Now it's only that this graph over here is an absolute value graph. Now, graphing absolute functions, some of the theory over here. This can be also called as a piecewise equation, which we studied in the last lesson. Why piecewise? Because you saw in the graph just a while ago, it's two pieces. There's a piece over here, a sharp corner, and then another piece. So it can be split up as piecewise as well. Now it's always V-shaped. Domain is all real numbers, but the range is all non-negative real numbers. Why? Because absolute value, you can use your calculator for a while. You have absolute symbol over here, shift and ABS. You can put any value, the answer is same. But what if you put a negative value? It will be positive. So it can't have a negative value for y. So that's why this is non-negative real numbers. But the graph can go down as long as it is transformed to the below sections. So we will see that now. Oh, before that, there is few last things to remember. Whenever something has been added, see, this is the standard form. Can you see this one? This is important. Now here, if k value is positive, the graph goes up. If it's negative, down. And over here, if it's positive, it's left, and negative is right. We will see it in an example. You'll understand much better. That's what these things say. Greater than means positive, less than 0 means negative. So here we have a graph. Modulus x, or absolute value x. First thing, you must know what is absolute x. If this is the scale, coordinate scale, x will be starting at 0 0. It's something like this. Okay, now here you can see this is the modulus x which I've drawn. If this is the parent function. Okay, modulus x. What does this -3 do? Minus 3, first of all, see whether it's inside the modulus, inside the lines or outside. X is alone over there, minus 3, that means it resembles the function. Let me just get this straight. Then it resembles the function f of x equals a modulus x plus, over here there was h, but that is not there, plus k. Now a, there is nothing, so it's a 1, so we can ignore this. It is like this, modulus x plus k. But here, what is k value? It's minus 3. Whatever is this k, it's the vertical section, this y-axis, okay? I'll just write k for understanding. Now it's minus 3. That means this point goes down 1, 2, and 3. The minus 3 value. So the graph will be just translated down by 3 units. The same thing is just going down 3 units. This would be the answer. Now you can see the graph. This is the graph. Here, all that is happening, what is happening exactly? You can see there is 0 over here, and that's been down 1, 2, and 3. So this is minus 3. Very simple, very straightforward. We will see other problems. Now here, there is important thing you must understand. If they don't ask you graph, if they ask just what's happening, you must tell what's happening here. The graph is translated down by 3 units. This is important. 3 units down. That's the correct answer. If it's MCQs of 3 units up, down, right, left, it is 3 units down. That's important to know. Then just graphing. Now, what about this one? Now, here you should see it is inside the absolute symbol, right? Inside the absolute symbol, we have 4. Now, always remember when it is inside, now if you have a graph, absolute value, it must be straight lines, okay? If it's minus, it goes to the right side. If it's plus, it goes to the left side. Why is that? There are various ways to understand this. One way is solve this. X minus 4 equals 0. What is the answer? X is equal to positive 4. Another thing is the given standard form is x minus h. Okay, modulus, the straight line. Now, what is h? It's just 4. Minus and minus is same. It's only 4. It's positive 4. Okay, that is one other way to understand. Or you can just remember whenever you see a minus inside this modulus symbol, take it to the right. Minus, it's not left, it's right over here. 1, 2, 3, 4. And draw the absolute value over here. That would be the original graph. I mean, this is the equation, graph of this equation. You can see the answer. It's the right side, 1, 2, 3, 4, and that is the answer. Very, very simple. So we will look into some other problems. Now here it has moved to right, okay, 4 units right, that's it. Because over here it's minus 4, that means it's 4 units right. And here we have got 2 of these transformations together. That's fine, we will do these now. What are these transformations? Here you can see the transformation of, x minus 2 and plus 3. In the transformation of linear graphs, okay, what happened? If it was x minus 2, there was brackets, plus 3, we can simplify this. Minus 2 plus 3 would be plus 1. And I can graph this, right? But here, this is not brackets, it's absolute or modulus symbol, absolute value functions. You can't do this over here. These cannot be solved. The way to solve it is, you have studied in the previous module, it's different. There are 2 cases to solve it. So you can't simplify it. So the graph would be, now if you have the graph, say, it starts from 0, 0, but don't start here. It's minus 2, that means it goes to right, 1, 2. And it goes up by 3 units, so it's 1, 2, and 3. So this is the point over here. The graph will be something like this. So let's see the graph here. Let's see, 1, 2 to the right, 1, 2, 3 to the to upside, 3 upside units. So that's it. So it is what? 2 units right and 3 units up. That's how we graph this. Okay, this is the parent function. It's always at 0, 0. It's just for reference. This is the correct answer. Okay. That's what is happening. And now then we can see one more graph. Okay, there is graphs given. You need to tell the function. So you need to know the standard form. The standard form is very simple. It is given as a is outside x minus h modulus symbol plus k. Or you can just remember it simply. This a we will study in the next example in the next topic. Here, this blue is the parent function f of x. What is happening here? One unit to the right, right? One to the right side. So it'll be x minus 1. If it's the right side, it's written as minus 1. Use the modulus symbol. Now, is it going up or down? No, that's it. Plus 0, but we don't write plus 0, so it's answer my x minus 1. That is it. That would be the answer. It's just going 1 units to the right, so you must write x minus 1 with the modulus or absolute value symbols. They're the two straight lines. That's it. This means whatever is inside this will only be positive answer. See, that's why there is no part of the graph down, right? It's all above. Or sometimes there will be transformation. We saw over here it went up, but if it goes down, it's fine, but all units from that point and upside. So that's how it is. Now okay, again, we need to write the equation. What about this one? Very simple. I'll simply do it in the graph here itself. You should just see what is the transformations that's happening here. 1, 2 to the left. So it'll be x plus 2. If it's left side, it'll be positive. 1, 2, 3, 4, and 5. 5 to the 5 down, it'll be up minus 5. Sorry, this is 5. Minus 5. That would be the answer. X plus 2 inside the modulus symbol, minus 5. And over here we have x plus 2 minus 5. Don't need to do all the steps. Directly you can write the answer. Very simple, very easy. Just make sure you mark these points. If it's writing, just mark these points over here. You can write this equation. If it's easy to remember, directly write the answer. You will get full marks. So this is how we can solve it. I hope this is clear. Only with the x-axis, as it goes left, it will be plus in the answer. As it goes right, it will be minus. Because the standard form is different, that's why. Now, what about dilations? We have learned a bit of dilations before. Dilations is basically change. It's not going to move right, up, down. It will just change the graph, how it is situated. Now, we will see over here, there are 4 important things. What I'll do is, I'll just give you examples over here. Now, if the values are greater than 0, see the a value, see now we will deal with the this a part. Oh, sorry, this one, a part, a x minus h plus k, right? This part, this is very important. This can be even inside inside the bracket. Now I will show you. I'll just remove that because, say for example, I have graphs bigger than, say you should have value bigger than 0. I will take say 5, and then I have modulus x over here, and less than 5, less than 0, but sorry, less than 1, greater than 0. See, the conditions are x must be greater than 1, x must be greater than 0 but less than 1, and same thing, x must be greater than 1. Sorry, it's not x, I'm sorry, it's a. Okay, it's a must be, a is this value over here, the constant. A must be less than 1 but greater than 0. So these are the conditions. So you can take anything greater than 1. Don't take 1. You can take 1.1. Fine, it's greater. 2, 3, 4, 5, anything up till infinity. But here you can't take any values. It must be 0.01, 0.2, 0.3, anything. Up to 0.999 you can take, but not 1 or not 0. I'll take 0.5. Modulus x. Here now, this is both vertical, okay? It is all vertical. And this over here is horizontal. When it's horizontal, it will be inside the modulus symbol, inside the 2 lines. That is greater than 1, I will take say phi itself, it's fine, x. But here now it's inside, it'll be less than 1 but greater than 0, 0.5. You can change these numbers, it doesn't matter, it's just for understanding I've written it. Now what happens is you must by heart these. For this, there is vertical because now it's outside the modulus. See, the modulus or absolute value, it's outside the absolute value symbols, right? So now we write it as vertical. If I tell modulus, I mean these two lines. Modulus also means, only positive value. So sometimes, it's interchangeable. Sometimes we call absolute as modulus as well. It's fine. Now, here, again, it's vertical. It's so easy because whenever it's out, it is vertical. Now, what about this? This is horizontal, horizontal, and this is also horizontal, horizontal. Now, here, vertical, if the value is greater than 1, it is stretched, stretch, okay? Now, what happens is, if you have bigger than 1, if this is the parent function, your transform function, because it's phi, it'll go upwards, closer to the vertical axis. So it is becoming stretched. You're stretching it where? To the vertically. It's going closer to this x-axis. As you increase the slope, as the number increases, it goes closer to this line, okay? Closer and closer. So that is why it is called stretch. What about the 0.5? Now, if it's 0.5, it goes below the parent function. It's going towards the horizontal axis. Now, vertically, if you see from this point of view, if vertical axis, it is going away. It's compressed. Compressed is less. Stretches towards, compressed is away. That is what you need to understand. When phi is outside, it is vertical, but if it's a big number, vertically it will be stretched. Now, if it's a small number, it will be compressed vertically, okay? What about this horizontal now? It's the opposite to this. If it's vertical stretch, big number is vertical stretch, it'll be horizontally compressed. Why? Because I just now showed you, see, it is being vertically stretched because it's going close to vertical axis. But what about this axis? It's very far from here, so it is being compressed horizontally. If you consider from horizontal axis point of view, this point is going away. See, it's very away. So it's compressed. And what about this? If it's 0.5, it's going towards horizontal axis, so it is stretched horizontally. So these are the 4 cases. Please try to remember these cases. If the number is bigger than 1, it will be vertically stretched. Less than 1 or greater than 0, vertically compressed. But for vertical, it must be outside the x. But when it's inside, it's horizontal point of view now. When it's bigger number, it's compressed horizontally and stretched when it's small number. These are the 4 cases. Please do remember this because these might ask, the question might be given like this over here. And what is happening here? It's vertically compression. That's how we solve this. Now, that's what is mentioned over here, A is greater than all this. So we will quickly see this one. You can see there's a number outside x modulus x. Now, what does this mean? It is relating to vertical. What is 5 by 2? If you use a calculator, you'll get 2.5, right? So it's greater than 1. Now, here, just looking at this, I can tell it's vertically stretched. Now, graph, how does this graph work? See, over here, they are doing table. You can do the table, but since it's a simple graph, I'll tell you a shortcut. You know the slope. We have learned the slope in the previous lessons, especially the graphing part. Now, what is this? This is the slope here. Phi by 2. Slope is given by y-axis. Change, okay? Change in y-axis. So I will write d for change, d, dy, and dx, okay? This is the small change over here. So what is this? Y means y-axis. So I should just start counting phi units in the y-axis. Top one is always y, top is phi. So this is the parent function, blue one. Now we are dealing with green. That is the answer. But how did we get it? 1, 2, 3, 4, 5. What is the x-axis? 2. So 1 and 2. So we must have a point in the graph here, and we know at 0, 0 there is 1 point. Take a ruler and just mark it. Okay? And you can also, because we know it's reflected to the left side, you can also take it to the left side, 1 over here. Sorry, 1 and 2 over here, this point. So that will be the 2 points, and then join these points like this, straight line, okay? With this ruler, you will get this answer. This is the graph. So it's very, very easy to graph it like this, provided you know the slope. Only thing you must remember is upper part is y, down part is 2. Now look over here, there is no other transformation. Plus, minus is nothing. It's only dilation, right? So it's very easy. Consider this to be the slope and graph it. That's how we can easily graph this up. Or you can use the table method. We have done this before. For the table method, take values less than 0, greater than 0, because it's modulus, right? Both values, less and greater. Then you need to substitute this over here. Directly you can do this. You don't need to do this step over here. Directly you can do this. What you need to do, minus 4 will go in x, and put it in the calculator if you want. I'll show you one value. All you need to do is minus 4 is x. So 5 divided by 2, modulus is given by shift and ABS, minus 2, minus 4, sorry. You can take any values, it's fine. It's 10. So x value should be assumed. These are assumed less than 0, greater than 0. Y values are found out from the equation. Now you change this to 2. 5. Next one to 0, it will be obviously 0. Why? Because anything multiplied by 0 is 0. And now what about the next one? 2. And lastly, we have, it's 5. Lastly, we have 4. See now, these two, it repeats over here. Why? Because whatever it's negative or positive, this will make it positive, right? So the answer will be the same. That's why. That's how you do graphing. But you can directly take it, directly do the graph. Or if it's MCQ, it's very easy. If you have 4 options, you can easily find out which is the correct graph, because it's 1, 2, 3, 4, 5, and 1, 2. That point must exist. That's it. We will look at this one now. Again, let's directly see the, okay, let's see this graph. It's very, very easy and simple to directly graph this. How? Let's look over here. What's happening? It's 2. So dy by dx. There's nothing down, so you can write 1. Always, if there's nothing, it's divided by 1. Because it's the same answer, 2. So now what is the y-axis? It's 2, right? So let me point out over here. 1, 2. What about x-axis? It goes 1. So this is the point. This 1 point, this 1 point. Draw a straight line, you'll get it. That's it. Okay. So that's how you graph this. And you can do this table if you want, but you can do straight away. No need of, yeah, this is directly. See, you're getting the answer. No need of this column. You can directly put this and write this column. Not even require this column. You can directly point it out. You can see minus 4, 1, 2, 3, 4 is having 8. This would be 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's how we do it. Okay, now important thing. What's happening here? It's a big number inside the modulus symbol, so it is horizontally. It's horizontal because it's inside. But if it's greater than 1, horizontal will be compressed. You can see from the period function, it's going upwards towards the vertical axis. Means it's compression to the horizontal axis. That's why horizontal compression. Now, pause the video right now and try to solve this by yourselves. These are easy, pretty easy problems. Now I will solve these. I hope you have tried it. Match each description with the dilation with its equation. So now here you can see these two are inside the bracket. So what would you do? When you look at this inside, this is horizontal, H, horizontal. Outside will be vertical, vertical. Let's see which numbers are bigger than 1. This is bigger than 1. It's stretched. Vertically, it will be stretched. Now, this is bigger than 1. It's 1.333. So, horizontally, it will be compressed. If it's bigger, vertically, it will be stretched. Horizontally, it will be compressed. Or you can just remember 2 of these. What happens? Big number, vertical stretch. If it's big number, horizontal will be the opposite thing. Compression. Now, this 1 by 5 is 0.2. So, horizontally, it will be stretched. And now 5 by 7 is 0 point something, 0. 6 or 7. So here it will be horizontal compression. If this numerator is lesser than the denominator, it will be 0 point something. If it's bigger, it'll be more than 1. So that's how this is it. Now let's join. It's vertically stretched here. Stretched vertically or vertical stretch, it's same thing. Compressed vertically is down here. Stretched horizontally is here. And lastly, we have compressed horizontally. I hope this is clear. It's very simple, straightforward. Now we move on to again dilation. Okay, relates to the graph of the parent function. It's same thing, but it's just that we have to again graph. That's the same what we have done just now. So I'll just tell you, okay, I understand what's the difference. In the previous one, we had numbers greater than 1. Now it's between 0 to 1. That's the only difference. So I'll directly tell you how to graph these. Very simple again. Count this. Here, 1 by 3 will be what? Dy by dx. Now, x is 3 units, y is 1 unit. 1 unit y, 3 units x. Y and x. First is y, then x, okay? So let's count 1. Here, this is the point. Now, what is happening to x-axis? It's 3. Let's count 1, 2, and 3. So you will have the second point here and the first point here. Draw a straight line. The same thing here, 1, 2, 3, this point. Draw this. That's it. That is how you solve this problem. I hope this is clear. This is how you can easily graph any of these dilations. Dilations are very simple. The center will be always 0, 0 because there is no transformation along the x or y axis. Only dilation over here. Next, we will move on. I hope this is clear. Now, if you're thinking about what sort of, compression or stretch is going to happen, it's going to be vertical compression. Why? Because it's less than 1 and it's outside the x. So it's vertical compression. Next, over here, after this problem, we have graphs. How do we understand what is the equation? Now, this is interesting. It's up to you. You can write it as vertical compression or horizontal. You can choose whether it's vertical or horizontal. That doesn't matter. It depends on the options. If it's writing, both are correct. Now, how you would do this is, the easiest method is this. All you need to do, see the graph. Now, can you see it? Is it touching the next point? Is it touching this one? No, this line, no, it's not touching. The graph is not touching there. So it's not easy to go to 1. So what about half? Let's see, this is somewhere half. Let's see, where is it? Okay, this point is half. Same thing over here. It's not touching this 1 over here. Let's see, where is half over here, right? Yeah, this is half. So we will do x over here. X value as 0.5. Here the y value is 0.5, okay? So we know the slope is dy by dx. Same thing here. What is the y here? Y is 0.5. What about the x? Let's count. 1, 2, 3, 4, right? It's at 4, we are getting 0.5. So divided by 4 units. So what is this? It's half into 1 by 4. That is 1 by 8. That's the answer. You can do it in calculator. 0.5 divided by 4. You'll directly get this. Here, what is happening? 0.5. But what is the y value? It's 1, 2, and 3. Then 0.5. So y is 3 divided by 0.5. So it'll be multiplied by 2 over here. It'll be 6. That's it. If you're getting confused with these direct, you can use calculator and check. All you need to do is put the 0.5 divided by 4. The answer is 1 by 8 or 0.125. Here you have to just do 3 divided by 0.5 or half. It's 6. Okay. So the answers now here, it's up to you. Let me just try. It's 1 by 8 modulus x, or you can also write this as 1 by 8x, but this will be vertical compression, this will be horizontal stretch. Here what happens, you can write it as like this or like this, and then here it is horizontal compression, vertical stretch. These would be the answers. So you can see this is 0.2125, 1 by 8 is 0.125, so it's the same thing. So just beware, and over here is 6. Now, if they mention you do it horizontally, then make sure you write it inside. If it's vertically, outside. That's it. So make sure you see the graph. Here, I hope this is clear. Now, how do you do is dy and dx. So what is the y-axis here? You can't take 1 because you can't extend the graph by yourself. Don't extend, just see 0.5. It will be there, 0.5. So 0.5 is middle of this, right? You got a point. Then count the x-axis. 1, 2, 3, 4. So it is 0.5 is y-axis divided by x-axis value 4. That's it. Here the same thing. Y-axis is 1, 2, 3. What about x-axis? Half. So 3 by half. We will move on now to the next type, reflection. Another easy topic. Reflection is always plus or minus values. Now then, we will see how to do this. Here, this is important. We saw we have been multiplied. See, these values are there, right? 6 or 0.25. What if outside the modulus there is minus? Inside the modulus, if it's minus, there is no point. Why? Even if you have minus 6 here, it will be plus only, right? If it's outside only, then it will be reflected. Where it reflects, it's downwards like this, okay? That is what we will learn now. Reflection. Now here it's mentioned if it's inside the brackets, it appears to be the same, because if you have negative sign, it doesn't matter. Only if it's outside. See, if it's inside, it's the same thing. Minus 8 doesn't matter. Only when it's outside, it changes. Let's do a problem and we'll see, understand it properly. Let me just do this over here. Let us draw axis of relevance over here. Say, sorry. Okay. Now it starts from 0, 0, but see that there is transformations. What is the transformation? Plus 3. That means you go to the left side when it's inside the bracket. Don't forget it. 1, 2, 3. So whenever that is inside along with x, it's always like this, out left side. What about this plus 5? So it's up 1, 2, 3, 4, 5. So this is the point. Now where does it correspond to? It corresponds to somewhere over here. So this is the point. Now we would draw the graphs upwards, right? But see, this minus sign is outside. So this is the point, correct? Just draw the graph downwards. That is the answer. That's it. Nothing else. You don't need to do this table and everything. If you understood this thoroughly, transformation, you can easily plot it out. Look over here. 1, minus 2, minus 3 is over here. So that's what we got, minus 3. And what about 5? 1, 2, see, its units are 2. 2, 4, 5 is in the middle. This is it. Downwards. That would be the answer. Okay. So depending on the scale, it might just vary the shape, but the answer would be the same. Here, there are a few things that's happening. You know, the graph parent function, it's going 3 units left, 5 units up, and reflected along where? Along the x-axis downwards, okay? Reflected along the x-axis. Means instead of going up, it's reflected downwards. Now, what about this graph? It's the same thing. We will directly see the graph and we will solve. Over here you can see, since there is no transformation, see this x and y plus or minus is not there. It will always have its center at 0. That doesn't change. What is this 3 by 4? 3 by 4 means dy dx. Don't consider the minus now. Let's keep it at the end. Y-axis is 3. So 1. We need to consider the minus, I'm sorry. Or you can do one thing. If you take it up, then you are to reflect it. So minus means you know you're going downwards. Okay, it's downwards. Don't worry about this x. Doesn't matter. Both the sides, it's fine. This minus means just this y-axis, put over here. Take it downwards, okay? Now, x is 4 to the right. Let me do that. 1, 2, 3, and 4 to the right. Or you can go to the left. It's the same. You have to do both. 1, 2, 3, 4 because it's absolute value function. What about this? Minus 3 means down. 1, 2, 3. Over here, this is the point. Same thing here. 1, 2, 3. This is the point. Now join these two lines downwards, you will get the answer. It's down because it's negative. If it was plus, it would have been upside. That's how we can easily graph it up. So directly, don't go to do the parent function. Directly you can go over here, provided you know dy. Y means this is 1 2 3 downwards and 1 2 3 4 right or left. So here you can see this is now negative, is outside. It doesn't matter what is the sign, always see what's the number. Is it bigger than 1 or less than 1? 3/4 is quarter, 0.75. It's less than 1, so it is vertically compressed. And it's reflected along the x-axis because it's going down, minus sign. Now here we have this equation. Again, it's the same thing. I'll directly see the graph and do it over here. See this? Over here, it's very easy to understand. Minus 4, right? So, wait a minute, what happened? Okay, see, this is the thing. Minus is inside. What happens? Does it make a difference? No, it just doesn't make a difference. Whenever we have negative inside, the negative sign goes off. It's like positive itself. So whenever there's minus inside, remember it just as positive. So it's 4, that is dy by dx. There's nothing down, so it's 1. What do you need to do? Y-axis is 4. It's 1, 2, 3, 4, and 1 to the right. This is the point. So join this 0, 0 and this one. There is no plus or minus to x. There is no anything outside or adding to this. So it's 0, 0. It starts with 0, 0. Now here, what happens is when you're talking about reflection, you just tell it's a reflected across y-axis. Basically, there is no reflection. Yes, we understand that, but the reflection is inside. That means it's relating to y-axis. So even if it's related to y-axis, it doesn't change. Why? Because if you're changing this over here, it's the same graph, right? So we tell the reflection is along y-axis, but there's no change exactly. Okay, because always absolute value functions are reflected on the y-axis to each other side. It's like a piecewise. This piece is reflected along y-axis to the other side. Now here we can see this is greater than 0, but it's inside the absolute symbol. So it will be horizontal, but it's greater than 1, so it's compressed. This is another thing which you must remember. Now then, transformation of absolute value functions. Here we have to just put in all the translations together, like everything what we have studied now will be asked up together. So you should move it up, down, left, right, minus, everything. Okay, let's see a problem. We know this if it's greater than 0, what happens? This is just like a quick recap. You can just pause the video and go through all this. This is like what happens in horizontal translation, vertical translation, and what happens in the reflection. When it's greater than 0, it's upwards, less than 0 is downwards. Open downwards. Why? It goes like this, opening downwards. Upwards means opening upwards. And what do we have over here? Dilation or dilation. It's if it's greater than, what happens with horizontal? Less than, it's down. So this is it. Now we will, okay, they have given us options. Choose the phrase that best describes, okay, each parameters. You should tell what is happening to each of these parameters. How does it affect this? We will go with the easy one. This outside one is the easiest, +3. What does it do? It will just see, now this is the graph, whatever is the graph, +3 means instead of 0, 0, it will be upside by 3. So it moves up by 3 units. Let's see, it translates left, it translates down, compresses, translates up. See, this is the answer, okay? Up by 3 units. Now this next one, go over here, -2. What about this -2? So it's just 2, okay? It's not, but when you see -2, it's always right. Okay, so only 2, this is right. It translates right. Why? Because in this, if you see this, x -2 would mean it's going to the right. If it was +2, then it'd be go to the left. So that would be the answers over here. Translates right. What about this -5 altogether? You must tell whether it's vertical or horizontal compression. Since it's outside, it's horizontal. Sorry, vertical. Since it's outside, I got confused. It's vertical when it's outside. Vertical stretch because it's bigger than 1. And it reflects. Yes, this is the correct answer. It reflects and stretches vertically. This is minus 5. To the right, it's 2. And lastly, we have 3. So these are the answers. Let's see. Reflects and stretches vertically. Yes, translates right, correct, and translates up. These are the answers. The others are not correct. And now we are going to the last part of the problems. We have to, graph this. We have done this before. It's just that all these together. We'll quickly look at the graph and directly see it. See, over here, step by step is given. First, inside this plus 1, it means it goes to the left. You can see here, it is going to the left by 1 unit only. So 1 unit to the left, okay? Now, what is the next unit? Next thing, minus 4. It means it will go down by 4 units. You can see here, this is the 0. Over here, it was going left 1 unit. Now it's going down 1, 2, 3, 4 units down. This is it. Now, that would be the final answer, this orange colored graph. Translated 1 unit left, 4 units down. And what else? Okay, that's the final answer, okay? Okay, the domain and range. This is very important. Sorry, I forgot about that. The domain is all the possible x values. The absolute value has all real number as domain, because you can put any x value, doesn't matter, you'll get the answer. But what about the range? Can there be any part of this graph? Is there any part of this graph less than this point, minus 4? No. So it's all real numbers above this point, not below. So all real numbers greater than or equal to minus 4. It can be up to minus 4. It's fine. See this graph? It's fine up till minus 4, but not less than that. It should be always up. Okay? That is the range, because doesn't matter which x value you put, any x value, you will never get minus 5 as the answer in y. So you can try this, put any value, it'll take forever. You can put until infinity, but the thing is, you will never get minus 5. That is why this graph easily tells you the range. It's all real numbers greater than minus 4, greater than or equal to. Even you might get minus 4, but you will not get anything less than that. At minus 1, if you put over here minus 1, you will get minus 4, but you'll never get minus 5, and so on. And over here, again, we have another similar problem. But now here, there is a horizontal dilation inside and minus 6 inside. Don't think, okay, minus 6, so the graph will be minus, okay, let's just see. It's not going to be 6 units, right? No. How do you understand this? See, there are plenty of ways. One of the easiest way is this. I'll tell you. Whatever is inside, just equate it to 0. Okay? Now solve for x. 3x will be equal to 6, positive 6, when it minus 6 goes to the other side. X is equal to what? 6 by 3. X is equal to 2. Now, it's positive 2 here. If this was plus, then it would have been negative 2. But now it's positive 2. So I'll just remove that negative. It can be plus or minus. It depends on the equation. See here, plus 2 means it's at the right side, right? Just do over here the point. That's it. Now, what is this slope? Very, very important. Slope is, if you recall in the previous lesson, y equals mx plus b. Whatever is before x. What is before x? It's 3x. So slope m is 3. That is dy by dx. Now what is x? Nothing, so it's 1. So what I'll do is, from here, we know x is 2. From here, I will take 1 unit to the right, x value, 1 unit right or left, doesn't matter, it's the same. And 3 units up only, both the sides should be up. 1, 2, 3, this is the point. Or it's this one, 1, 2, 3, okay? This is the point. And just join those points to that particular point. So here and here, 2 lines, 1 line, 1 line. So this is how we can easily graph it, okay? The Shorter method, only when everything is inside, the translation inside. If it's outside, it's simple. You have done it before. Now, no, sorry, we have not done dilations and change in the x or y axis together. So you must remember this. All you need to do is whatever is inside the absolute value symbol, just solve it and find the x value. That is your base. See over here, x2. And then what you do is basically, all you need to do is, 1 second here. Sorry, that's correct. Whatever I told, I just got confused with the symbol again. Did I do it correct? But yeah, as it is, this graph is correct. Now here, if again, I'll tell you the table method as well. This table method is a very safe and secure way. Why? Because you can use this anytime, anywhere, for any graph, and you will get the answer. Table method is simple. All you have to do is take x values. Now, taking the x values is a little bit difficult, because if you know this x value, then you must take some values less than that, greater than that. So that is why this method, the first method, getting the x, is always important. Why? Because that is the x-intercept. Okay, this basically you're solving the x-intercept. So do this, equate this to 0 and solve the x value. Now once you found the x value, take values less than this and greater than this. You can see here 2, less than 2 is 2, 1 and 0, greater than 2 is 3 and 4. This is very important for absolute value. Why? Because it's like a piecewise. Okay, now, what you do is put this 0 inside this. What happens? It'll be 3 into 0. It's 0 minus 6. Minus is dissolved. It'll be positive 6. So see, 0. When x is 0, it's 6 here. Now, what about 1? 3 minus 3, it'll be minus 3. But the negative sign dissolves. It'll be 3. 1 and 3, yes. Now, when it's 0, sorry, when it's 2, it's 6 minus 6, it's 0. So it'll be 2 and 0. This is the point. Same way you can start increasing 3. 3 times 3 is 9, minus 3 will be positive 3 itself. Not 3 and 3. Again, you can keep on going. You'll get this response. This is by the table method. Okay. Now, what is the domain? Domain does not change. It's all real numbers. You can see the domain over here. It's always all real numbers. But what is the range? Is it going up or down? No, it's at the axis. So all real numbers which are greater than or equal to 0. That is it. If it was somewhere down, it would be greater than or equal to that particular point. Now here, the vertex, this is the vertex basically. Forgot to tell you, this is the vertex where the two lines join. The sharp corner or the end. Wherever that touches, see where the graph is pointing, upwards or downwards. If it's upwards, it's all real numbers greater than or equal to 0. If it was, say, downwards like this, then what was the domain? It would be all real numbers less than or equal to 0, because it's going downwards. Okay, that's how we do it. Now, again, we have one more problem. It's different. Now it's straightforward. Let me just do it from the graph. We have minus 3, that means it goes to the right. 1, 2, and 3. This is the point. Now, what about this plus 5? It makes it go up. 1, 2, 3, 4, and 5. This is the point. So we got these 2 points. Next, what? This minus sign will reflect. So don't make it upwards, go downwards. That's it. That's how you get this graph. When you point it downwards, it'll be, this is the solution. Now, what is the domain and range? Domain would be all real numbers, but the range, look here, it's downwards. So it's all real numbers less than or equal to this point. What is this point? 5. This one, 5. So it's less than or equal to 5. That's how we get this answer. That's it. If you have understood one or two problems, this is the third problem in the same topic, same thing, So if you understand one or two, you will easily understand the others. Make sure after you understand one, try pausing the videos in the middle and solve them by yourselves. Okay. Now we have a real world problem here. Example 15, very lengthy, right? So many examples in this lesson. Apply graphs of absolute value functions. Now here we can see this particular determine an absolute value function that models the shape of the Palace of Peace and Reconciliation. Now this is the Palace of Peace and Reconciliation, and now you can see its shape is in terms of an absolute value graph. You can see this is the vertex, but it's going downwards, so negative sign. How would you graph it? So the easy way would be, I will start just graphing. We do not need to graph it. We need to write the equation. So the easiest way would be understanding this vertex. Okay. This vertex over here. How much, what is the slope from this point to this point? There are various ways to do it. One way is the slope equation. M is equal to y2 minus y1 divided by x2 minus x1. Okay, this is one way. What is first point, second point? You can choose x1, y1. If this is x1, this must be y1, can't be y2. So then the next point will be x2, y2. Or you can even consider this as x1, y1, x2, y2. It's fine. We will do this. M is equal to, what is y2? It's 62 minus y2, y1 is 0 divided by 0 minus of minus 31. So what is the slope here? The slope would be 62 divided by uh, 31. That's 2. Here the answer is 2. So now the slope is 2. But what about the graph? What about the other things? Okay, there is one thing now I remember to explain. Here, isn't the slope supposed to be negative? What happened? If I take these 2 points, now you'll understand. Let me just take these 2 points 1 second, then you'll understand, then we will dwell on it. So x2 over here, this will be x1, this is y1. So now I will do m is equal to y2 minus y1 by x2 minus x1. M equals, what is this? Y2 is 62 minus 0 divided by 0 minus 31. That is equal to 62 by negative 31. That's minus 2. Is the slope different in both the sides? See now, if you're considering the single value, see this absolute value, we know there will be minus sign outside. Okay, outside it will be a minus sign, but that's why it's going down. But if you look at this line individually, it's increasing. Do you agree? Only this line, it's increasing from down to up, it's going upwards. Whereas this line is going downwards. So here at the right side, you will have negative slope. Why? It's going down. Left side, you will have positive. Why? It's going up. That doesn't matter, plus or minus. You need just the value 2. But you must realize, because this is downwards, opening downwards, there will be a minus sign in the answer. So this is the thing. Okay? I hope this is clear. Now there is one more method instead of this formula. If you forgot the formula, you cannot forget this formula. It's so easy, but in case you want to do it other way, how would you do it? It's again very easy. You have this point, right? Start counting from year to year. How much is it? Y, this is y, dy, okay? Dy, it is 62 from year to year, 62 units. From year to year, how much is the units? It's 31. So dy by dx, even over here, it'll be 31, okay? Dy by dx would be 62 by 31. That's also 2. If you take it left side, you can consider minus 2. It's fine. So this is how we get the slope. Now, once we get the slope, what else do you need? Slope is done. Now, let's recall the function. Y equals a modulus x minus h plus k. What about k? It's going up. See now, over here, is there any move to the right or left from this point, the vertex? Where is the x value, h value? That is, whether it's right or left, it's 0. So h is not there. This is 0, gone. So you're remaining with only x over here. What about this k? It's going up by what? 62. That's it. Now the slope was negative because it's going down, and 2. This would be the final answer. Okay, so that's it. That would be the final answer here. Now it's very, very simple. Now don't think, okay, I have taken slope. See over here, they have taken the slope from the right side. You're getting minus 2. But now what if you take it from the left side? You will not get a minus sign, but looking at the figure, you must write this minus. Is that okay? So yes, right side it's going down, but this is a piecewise. See, positive, negative, okay? So please, but if you count the slope like this, left side would be negative, but you must understand, since it's opening downwards, this is the minus sign, slope is 2. Over here, there is no change in the x-axis. It's at 0. X is 0 over here, the vertex. So it's only x plus upside 62. So that's why this is the final answer. You don't need to do anything else. Directly you can choose the answer. That's how we do that. The final answer, this is the equation that models the shape of the Palace of Peace and Reconciliation. Sorry. Now, okay, the last problem I believe is the check 15. Okay, highest number of problems in a lesson, I guess. Apply graphs with absolute value function. Again, look, I will directly show you the final answer. There'll be minus, and then we have to just find this slope. Let's do it anyways. Say this minus over here, slope, and this thing. Now we will see how to do it one by one. Sorry. First thing, let's write the equation. It is y equals a x minus h plus k. Let's see what is the vertex. Is there any value? Yes, it's going right by 9 units. If it goes right, it will be x minus 9. Okay, this will be minus 9. H is 9 here. This is h and k. Okay, sorry, h and k values. Vertex always will have the hk. This is h. But I told you just remember right side is minus 9, so you can remember like this. What is the k? Upside by 1 1 0 0 1 1 0 0. Very easy. Only this slope is remaining. Now you can just take any 2 points and find the slope. I'll take the first and this point because it's easier. Now don't count from here like this. No, see over here there is 29. That means it's up. It's not at 0 0. It's 29. So be careful. So if you consider this as x1, this is y1, x2, y2. What happens? M is given as y2 minus y1 by x2 minus x1. The answer would be 1100 minus y1 is 29 divided by x2 is 9 minus 0. The answer would be, okay, just use your calculator, it's much easier. Okay, I'll just use the calculator here. Just up with this 1100 minus 29 divided by 9 minus 0 is 9 itself, and the answer is 119. So here it's not just 119 minus 119. Don't forget it'll be negative 119. Okay, that is the answer. Let's see the final answer. It should be the same. Yes, it's minus 119, and inside the absolute value modulus symbol, it'll be x minus 9 plus 1100. So this is how you solve this problem. Very simple with the slope equation, and then see what is happening. Now always remember this vertex, right? When you look at the vertex, you will have h and k value. So now if you're writing this equation, see where is this joining point. H is directly 9. Leave this x minus, h is 9, k is 110. Directly you can do it, okay? But when you're graphing it, this is not so important, the vertex, because you need to move the vertex, right? So always see if the given graph is minus 9, take 9 units right and up, so units. So that is how we can easily solve it up. Okay, finally we have come to the end of this lesson. Thank you very much for watching this till the end. If you have stayed till here, well done. Please make sure you solve more and more problems by yourselves. And if you have any doubts or questions or anything, please do put in the comment section and I'll try to get back to you as soon as possible. And if you're not yet subscribed to my channel, please do considering subscribing it. It's free to subscribe, but it would mean so much to me. And also, if you have found this useful, please do hit the like button. That would mean a lot to me. And do share it with your friends, whoever might find it useful. Thank you, guys. Until the next video, bye-bye and take care.